Student, welcome to Mr. Chen's master class, and this one is for pre-cal honors. So this one it's section 4.4, which is the same as 6.3 from the James Stewart textbook. Okay, so which is the fifth edition pre-cal. And the one that I want to talk about today is about the trigonometric functions of any angle. So let's say that if theta is an angle in standard positions with xy, the coordinate xy, and on its terminal side, then the following definition apply. So again, it's all about what we've been doing using the definition of x, y, r. So let's say that we do have a triangle in the first quadrant, a right triangle. So the x component, it's always the horizontal component, and then the y component, then that'd be the vertical. So let's say we do have a point x comma y. Okay, so here's x, here's y, and then r. So the way to define r is about using the Pythagorean theorem. Okay, so which is this one right here. And then sine of theta. So what we got, theta, it's just the angle which is constructed by in between the x-axis and the terminal side. Okay, so here's the terminal side. And then sine of theta, so then that we consider y over r. Cosecant of theta, r over y. So we talked about that previously for the earlier sections. So cosine of theta, so then that'd be x over r. Tangent of theta, y over x. And then secant of theta, so r over x. Cotangent of theta, so which is what? R. This one would be considered x over y. And you may notice that this one, they're just the reciprocals identity and all the reciprocals. And determine which points are in the unit circle for which each point find the value of sine of theta, secant of theta, cotangent of theta. So where the point x comma y, it's on the terminal sides of angle theta. So this one basically gives you the xy coordinate. Okay, so we do know that it's in quadrant, this one is positive, negative, so it's in quadrant 2. So again, this one is just approximation, so somewhere over here, quadrant 2, the point. So it's 1 over 3 root 5, and then comma, negative 4 root 5 over 15. Oh, you know what, it's not in quadrant 2. It's supposed to be in quadrant 4, because that's positive, negative, excuse me. Okay, so positive, negative, quadrant 4, right here. Okay, so the terminal side. So it's 1 over 3 root 5, comma, negative 4 root 5, and then 15. Okay, so one thing that you want to find out, it's that the sine of theta. So here's theta. So you might be using this one as the reference angle. So sine of theta, then that'll be considered, well, first thing that you want to find out, it's that the radius. Okay, so let me take this one to the new page. Just want to get more space to show word for this. Because the numbers there, x, y value, they're a little bit complicated. Okay, snip. Okay, so let me just put it right here. Okay, so once again, the x, y values, so they're given already. So the one thing that I need to find out, it's that r, radius. So using the Pythagorean theorem, so square root of 1 over 3 root 5, quantity square, and then plus negative 4 root 5 over 15, quantity square. Okay, so got to be very careful. So 1 over 3 root 5, quantity square. So it's 1 over 9 times 5. So which is what? 1 over 45. And then negative 4 root 5 over 15 quantity square. So then that'd be positive 16 times 5. So 16 times 5, then that'd be what? Then that'd be 80 over 15 quantity square. So 225. Okay. So it's a very big number. And then you want to find out the common denominator, combine them. So common denominator looks like, then that'd be what? 225. So multiply this number by 5, top and the bottom. So we got 85 over 225, square root of the whole thing. Okay, so square root of the whole thing. So what we got here, so it's root 85 over 15. Okay, for that radius. And now finding that the ratios. So again, we do know that the point, the terminal point, it's right here in quadrant 4. So 1 over 3 root 5, comma, negative 4 root 5 over 15. Again, theta is going this way because that is what? It's going by counterclockwise, positive. So what we found here, using the ratio, so sine of theta, y over r, so which is what? Negative 4 root 5 over 15, divided by root 85 over 15. So basically this one is just multiplied by the reciprocal of the denominator. And then this one just find things out, cancel. So 15, 15. So what we got here is negative 4 root 5 over root 85. And then from here you want to rationalize it. So rationalize it. So this number is divisible by 5. Okay, so divided by 5, top and the bottom. So what we got here, which is what? Over 17, root 17. So negative 4 over root 17. Rationalize it. So negative 4 root 17 over 17. Okay, so that's sine of theta. And now let's see what else that we need to figure out here. So secant, cotangent. Okay, so for secant, so similar. So secant is what? R over x. So then that would be considered, well, r, the one that we found, which is root 85 over 15, divided by x. So divided by this radical, so that means multiplied by the reciprocal. So 3 root 5 over 1. Again, things that we can cancel here. So nothing we can, 3 and 15, reduce. So root 85 times root 5. So then that would be 5 times 5, 25. 8 times 5, 40. Plus 2, 425. And then it's all over 5. And then for 25, let's find out things that is reducible. So this one is consists with 25 times, well, 25 times 8, that's 200. So 8, 16. And then 17. So reduce it. So it's what? This one is just consider root 17. Okay. And then what else? Cosecant. Making sure that we're looking for that, the same ratio. No, cotangent. Excuse me. So the next one, the last one that we need to find out is cotangent. So sine, secant, and cotangent. So now for cotangent, let's put it up here. So that one is what? The ratio, x over y. So what we found here, x, so it's 1 over 3 root 5 divided by y, negative 4 root 5 over 15. Again, so basically just multiply by the reciprocal. Okay, and then straight across, so we got 15. So 3 times negative 4, negative 12, times 5, negative 60. And then reduce it, so it's 1 over negative 4. Just like that. So make sure that you'll be able to use the formula wisely, carefully. Okay. So now let's see what else that we have for the rest of this. So again, this one is the exact same lesson on the James Stewart, which is sections 6.3. Okay, so trigonometric functions of any angle. So the other one, find the value of sine of theta, cotangent of theta, given that secant of theta. So again, draw the diagram, find out that it's what? Radius is 7, adjacent is 4, and then you want to find out the missing element, and find out that the angle. But make sure that this one is in quadrant 4. Okay, so try that 2b and 3 by yourself. And the other one I would like to talk about next, so then that'll be number 4. So number 4a, excuse me. So b is quite similar. Okay, so with the conditions. So cosine of t is greater than 0, sine of t is less than 0. Okay, so let's check that right here. So what this one shows that cosine of t is greater than 0, so the possibility for the quadrant number, it could be positive, it could be what? Quadrant 1, positive. Quadrant 1 here. And also positive could be what? Quadrant 4. And then for sine of t could be less than 0, then that would be considered either quadrant 3 in quadrant 4. So you want to find out the common quadrant, then that'll be quadrant 4. Okay, so that means angle T, it's right in quadrant 4. Going this way. So determine the quadrant in which the terminal point of the angle T lies. Okay, quadrant 4, that's what we found. So just find out the common quadrant. And then cotangent of T is greater than 0. Greater than 0, that means, well, it's going to be either in quadrant 3 or quadrant 1, right? Because that cotangent could be what? X over y. So negative over negative is still considered positive. Okay? So positive over positive or negative over negative. And then for cosecant of T is less than 0. So that means this one, it's in quadrant, well, cosecant, it's considered R over y. Well, radius is always positive, but y could be negative. So if y is negative, so that means it's either in quadrant 3 or quadrant 4. Okay? So again, find out the common quadrant. So the one that we have, quadrant 3. Okay, so all the way over here. So that's how you determine the quadrant number. Okay, so that one is pretty straightforward. And now let's see what else. And write the first expression in terms of the other, given that T, it's in the given quadrant. Okay, so now this one's getting a little bit complicated. So besides the quadrant, we need to determine that one of the trig function in terms of the other. So it looks like we need to apply some kind of identity. Okay, so again, let me just snip this one. Okay, so for number 5, okay, let me just make my cell phone into airplane mode. Okay, sorry about that. Okay, so here we go. So secant of T. So one thing that we notice secant of T, according to that, the Pythagorean theorem, so secant square of T, it's the same as tangent square of T plus 1. So in order to solve for secant of T in terms of tangent, okay, so write the first expression in terms of the other. So we can take the square root both sides, right? So take the square root both sides. So what we found here, it's considered secant of T. So that equals, well, this one could be plus minus. Now, so you might be wondering which one do we need to apply. For secant, if that's in quadrant 2, so secant, we do know that it's considered 1 over cosine. Okay, or this one could be written as r over x. So that means the x value here got to be negative. Okay, if this one is being negative, so that means we're using the negative radical. So it's negative square root of tangent square of T plus 1. Okay, and now what about for the other one? Again, using the Pythagorean identity. So cosine square of T is always considered 1 minus square root, I'll just put in that the Pythagorean theorem, the alternate form. So that one is just like 1 minus sine square of T. But now in order to solve for cosine of T in terms of sine of T, so again, take the square root. But once you take the square root, this one could be plus minus. And now, how do we determine the sine? So it's quadrant 3. So for cosine in quadrant 3, it's always what? Negative, because that's going to the left. So again, choosing the negative. So negative radicals of 1 minus sine square of T. Okay? And now what about for cosecant square of T in terms of cosine? So this one might be a little bit tricky. So cosecant, one thing that we notice, cosecant square of T, according to the Pythagorean theorem, it's like 1 plus cotangent. Okay, cotangent square of T. And also cotangent, this one can be written as cosine over sine. So it's 1 plus cosine square of T over sine square of T. Now, but the thing is that we're not allowed to use anything other than cosine. So that means for that sine square of T, we can use that, the Pythagorean replacement. So it's 1 plus cosine square of T over square root of 1 minus cosine square of T. Now again, it's about the matter of fact, it's in quadrant 1. So quadrant 1, that's easy to deal with. Everything is positive. So if everything's positive, so just state that as positive. Okay, so this one's a positive radical. Okay, so take the square root of this whole thing. Take the square root of the whole quantity. So cosecant of t is just the radicals of 1 plus cosine square of t over plus positive radicals 1 minus cosine square of t. So for part C, it's a little bit complicated, but it means that it's just the same kind of routine. So just rewrite everything in terms of cosine. Okay? And now let's see what else. And for the other part of this, so find two particular solutions of the specific interval and then give the general solutions of each equation. So this one is most likely is like going to chapter 7, but it's similar to what we did last year, solving the basic trigonometric equation. Okay, so we'll take a look at that. Okay, so for number 6. So this one just give you the early preparations of what the next chapter is all about. Okay, so solving basic trigonometric equation. Okay, let's put it right here. So find two particular solution in the specific interval. Okay, it's all about the quadrant number. So this one is already given, so that's just considered the specific interval. So tangent of theta, so we do know that's negative. Well, if tangent theta is being negative, so that means the solution can be found either in quadrant 2 and quadrant 4. Because tangent is considered y over x. Okay, so either y is being negative or x is being negative. So right here, so negative root 3 over 1. Okay, so let's just label it y over x, so negative root 3 over 1. So that means in the quadrant 4, so y could be negative root 3, and then adjacent x could be 1. And now what about the other solution? The other scenario could be in quadrant 2. So that means the negative sign, we can swap it. We can just put it either down the bottom or we can put it on the top. So the other way to rewrite it, it's root 3 over negative 1. So root 3, that's y, and then negative 1, then that'd be the what? The value of x. And you might be wondering, it's a special right triangle? It is. So the measure of the reference angle is considered pi over 3. Okay, so the measure of the reference angle is pi over 3. So what's the measure of those angle? So scenario 1, so in the second quadrant, pi over 3. So that means pi minus pi over 3. So we just want to get that angle. So pi minus pi over 3, then that will be considered 2 pi over 3. So that's the first solution. And then what about the one in quadrant 4? So 2 pi minus pi over 3. So this one would be considered 6 pi over 3 minus pi over 3. Then that would be 5 pi over 3. Just like that. Okay, so making sure that it makes sense. Yeah, it does. Okay, so 2 pi over 3, 5 pi over 3. So we found out the solution in the specific quadrant, in the specific interval. And now we need to give out the general solution. So once you find a solution here, if that's in general, remember, for the unit circle, we can go around that as many times as we want. Okay, so going back to what we did last year. So if we can go around the unit circle as many times as we want, and also we can go to either one of the direction, clockwise or counterclockwise. So in order to get that, the multiple solutions, so this one will be considered 2 pi over 3 plus minus 2 pi k, and where k, it's any integer. And also the other solution would be 5 pi over 3 plus minus 2 pi k. Again, just say that where k, it's any integer. Okay, so that's how you find it. And now, what about for something that's a little bit different, something that's kind of special? Okay, so let's do one of those. And what about for this one here? Because for the rest of those, they're pretty straightforward. 2 over 1, 1 over 1 for the ratio. But what about something like sine of x equals 0? So sine of x equals 0. So we do have two possibilities. So sine of x equals 0. So it could be either on the x-axis. So sine of 0 radian, or sine of pi. So x could be either 0 or pi. So this one, there's no need to set up any kind of special right triangle because that's a special ratio. It's 0. Unlike the one we have, root 3 over 2, 1 over 1, or 1 over 2, or root 2 over 2. So we found that. So this on the specific interval, so the special solution for this one would be 0 and pi. And now you might be wondering, what about the general solution? So the general solution would be considered 0 plus minus pi k. Okay, because once you add pi, you get that the other solution. Once you go around, you get what? 2 pi. And then once you keep going, and then you get what? 3 pi, 4 pi, 5 pi, 6 pi, so on and so forth. So plus minus pi k. So where k, it's any integer. Okay, so just like that. And then this one's for tangents. So tangents, so this one, 2 possibility, quadrant 1, could be in quadrant 4. Opposite over adjacent, or y over x, so 1, 1, and then could be negative 1 over negative 1. So it could be pi over 4, and also it could be 5 pi over 4. Okay, so this one's quite obvious. So pi over 4 plus pi, plus minus, well, once you get to the other ones, plus minus what? Pi k, like that. So it's relatively easy to handle, with the problem like this. And also this one, the one that we found, the general solution, instead of writing it separately, we can just put in like 2 pi over 3 plus minus pi k. So where's k? It's any integer. Because once you go around by 180 degree, you'll get the second solution. Okay, so this one, just try this one. So it's something similar to what we did. Okay, so that was number 6. And now let's see what else. And then the last one's kind of tricky. It's about the rotation. So you guys do remember that rotation back to geometry honors last year. And you guys might be wondering, well, it's a pandemic time. There's so many things being cut off. Things that you guys haven't seen that before. So that's why I'm showing you that right now. The rotation with the angle, all that. So either using a compass or using a protractor to find out the rotation. So sine of theta. So theta, this one is given very clearly. It's in the first quadrant. So for sine of theta, so this one you want to rewrite it in terms of the following, a and b, the coordinate. Okay, so here's the triangle. So here's a, here's b, and then the radius, we don't know what that is. We can always use the Pythagorean theorem, square root of a squared plus b squared. So sine of theta, so that one is just consider y over r, so then that'll be considered b over square root of a squared plus b squared, because you want to write it in terms of a and b. Rationalize it, so b square root of a squared plus b squared over a squared plus b squared. Again, using the formula first, so which is what? Y over r, and then just putting the replacement. And then what about tangent of pi minus theta? So pi, where's pi? Pi is over here, minus theta, so that means the angle, it's going to be all the way over here. Okay, so here's theta. So let's just set up the same kind of line, terminal side, like that. So here's pi minus, well, here's theta. So pi minus theta, then that'll be this angle. This one is still considered theta. But this part right here, pi minus theta. So this one is in quadrant 2. So in quadrant 2, again, this one is considered AB in quadrant 1. So right here in quadrant 2, then that'll be considered negative A and positive B. So negative A, positive B. So tangent, so what we found here, it's opposite over adjacent, or y over x. So which is what? B over negative A. Just like that. And then what about for cosine of 180 plus theta? So this one is going all the way to quadrant 3 then. Again, extend the line, the terminal side, all the way through. It's all about the reflection. 180. So in quadrant 3, so this one would be considered negative A, negative B. So again, hypotenuse, it's always a squared plus b squared with the square root. So cosine is what? X over r. So x here, which is what? Negative a. And then radius, square root of a squared plus b squared. And then for d, so sine of theta plus beta. Okay, so where's beta? So beta is all the way from the first terminal side to the second terminal side. So it's the difference of, well, it's being bounded with those two terminal sides. Okay, so here's beta. So you might be wondering, beta, how do we find that? Okay, so this one thing that we can do. So let's just add theta and beta together. So theta and beta, once you combine them, so this one, it's all the way over here. So you see that the point, terminal side, so C and D. Okay, so there's no need to change the sign, just use the exact same terminal point. So C and D right here. So that means the x component is C. And then the y component is D. And then the radius here, square root of C squared plus D squared. So sine, which is considered y over r. So y over r, so what we found here, so it's d over square root of c squared plus d squared. Rationalize it, so d times square root of c squared plus d squared over c squared plus d squared. So for those people who might be wondering, there's so many letters, there's so many symbols, angles, ratios, got to be careful with that. The lowercase letter, alphabetical letter, they're always considered the side length or the point, xy coordinate. But the Greek letter, it's always the angle. Theta, beta, sometimes like gamma, lambda, all those type of things. Okay? So got to be very careful. And then finally, the last one, so negative cotangent of 360 minus theta. So 360 minus theta, right here. So here's theta, but it's negative. So 360 minus theta. So then that'd be this angle. Okay, let me use different color for that. Then that'd be 360 minus theta. See that terminal side? It's always reflected. So that means at this point, so instead of being A comma B, so what is that? A is still the same, but it's negative B. Because the y value, it's in the in the fourth quadrant. So it's negative B. So what we found, so negative cotangent of 360 minus theta. So it's negative x over y. So it's negative, which is, what is that? A over B, so over negative B. Because the y value here, it's B, negative B. Okay, like that. So negative, negative, positive, so it's A over B. Just like that. Okay, so any question, any concerns, so make sure that you need to either rewind or fast forward the video. And also, you guys do like the channel, make sure that you subscribe it. There's so many things that coming up. I'm going to post up those stuff right there within the next couple of weeks, okay? Probably the midterm review or things that you have for the next couple chapters, okay? So thank you for watching it. So I'll see you next time. So you guys have a great one.